In this video we'll be looking at the components of the pacemaker or slow response action potential. This is the action potential seen in the cells of the sinoatrial and atrioventricular nodes. So if we take a look at the trace here, one of the first things you'll probably notice is the lack of a rapid upstroke as seen in phase 0 of the fast response action potential. This is because the pacemaker cells lack the fast response sodium channels that produce the rapid upstroke seen in the fast response action potential. In pacemaker cells, this upstroke is instead produced by a gradual influx of calcium ions through the same L-type calcium channels that produce the plateau or phase 2 in the fast response. Another key difference between the conductive and pacemaker cells action potentials is seen in phase 4 of the cardiac action potential. In pacemaker cells, the negative resting membrane potential activates ion channels that allow gradual inward sodium current, which decays the membrane potential over time towards the threshold, at which point another action potential is generated. This is known as the funny current or pacemaker current, and it's this that conveys the automaticity to the cells of the sinoatrial and atrioventricular nodes. That is to say, this current allows them to generate their own rate and rhythm. Phase 3 of the slow response or pacemaker potential is much the same as that seen in the fast response action potential. It's produced by potassium channels opening, increasing potassium conductance, and allowing an outward hyperpolarizing potassium current. So that's phase 3 of the pacemaker potential. So just to recap quickly, there's an inward calcium current through the slow activating L-type calcium channels that produces phase 0, the upstroke of the pacemaker potential. There's the gradual influx of sodium ions, the funny current or pacemaker current, which gradually decays the resting membrane potential to threshold over time, producing automaticity in the cells of the sinoatrial and atrioventricular node. And there's an outward hyperpolarizing potassium current that produces repolarization or phase 3 of the pacemaker potential.